Um, Look, it's good to see everybody. I'm not sure if everybody knows myself. I'm Stephen Moss. I'm with the college here in the sort of construction civil engineering end, and it's great to see so many. You can't hear me? No. I can hear myself perfectly well. Okay, I'll try that.
Yes.
Okay, didn't realise I swallowed it. Look, I'm just going to go through the boring stuff, and then we'll have Parag up to do a wee welcome and introduce the next speaker. We're delighted actually to have a really good lineup of speakers here today, and we're going to be hopefully seeing some amazing stuff that's going on in local companies, and as well as hearing from our keynote speaker, Dr. Yanis Paralakis over from University of Cambridge. So I'm really interested to hear what everybody has to say. Look, I'm just going to go through the basic housekeeping stuff just to be sure. In terms of fire alarms, we do not have anything planned today that I'm told. So if we hear a fire alarm, we don't need to evacuate immediately because there is a voice activated system here that will tell us what to do and to sit maybe in burn, but we'll follow what we see. In terms of fire exits, there's one behind us, there's one here, and there's actually double doors here, so I think we're all covered. In relation to facilities, toilets, etc., there are gents just straight across to the right of the lifts, and ladies is just up past reception on the left-hand side. Could I also ask, please, just in terms of respect for the speakers, etc., could we have mobile phones put on to silent, if at all possible? There is lunch available after for everybody that's attending. We would obviously like everyone to stay for lunch if at all possible. And just as a final note, if you haven't registered, can you try and be sure to register with us, because and Aidan has an iPad over there. If you haven't registered yet, it's very, very simple. It takes just a few seconds. And what it'll do is it'll allow us to actually forward all the presentations from the speakers for you to actually follow up. And there'll also be information in from the college as to maybe how we might be able to assist maybe in any of the aspects that we see, and maybe if you want to take them forward in your business, etc., and also how we might be able to secure some funding to help you do that. So if I had Parag McNamee, our head of the department, up, we'll do a wee welcome and things going. Thank you.
Good morning, everyone. I'd like to welcome you all here to the inaugural Future Technologies in the Construction Industry event. I'd like to extend a very warm welcome to our speakers today, whom we have a very impressive roster of expertise to talk to you this morning. And I'd like to extend a particular welcome to our listeners in China and Russia who are listening to us on live stream via the magic of the future technologies that we're here to hear about. It's good to see you all here. The construction department in Southwest College has always been one of the strongest departments in the college and has been growing from strength to strength over the last few years. We have, among many other courses, we're now offering a BSc in BSc honours degree in construction engineering and management at the Enniskillen campus, along with the University of Ulster. And we also offer 4 foundation degrees in construction engineering, civil and environmental engineering, architectural technology, and architectural engineering and energy, what used to be called building services and renewable energy. And we have developed those foundation degrees and through our continual work, we've developed very close links with industry through our Industry Advisory Board, and I'd like to welcome the members of the IAB who are here with us today. And we're carrying out, through the IAB and through the work of the Connected project, we're carrying out projects with industry, such as the very exciting VR project that we're carrying out with McAvoy, the McAvoy Group. I'd like to thank Lynn from Connected for the support for the event and for all her support over the past number of years. She's always been a very innovative and future-seeing person who's always given us a great deal of support in developing our work in technologies such as these and our work with industry. So would very much like to recognise and thank Lynn for that. the construction industry is an area where future technologies have been embraced very quickly as tools for improving how projects are designed and built and operated. From 3D laser scanning of areas to create 3D models, to virtual reality design tools, allowing real-time, simultaneous design with clients, to augmented reality tools that allow it to be very easy to see that something is built as designed. From drones doing GIS and aerial surveys and topographic and infrared surveys, to Internet of Things applications with sensors monitoring traffic flows, material wear, movement subsidence, from intelligent BIM models, sharing information simultaneously across a number of different plans, and then allowing those plans to all be updated on the hoof as the building progresses. It's now possible to gather all that data together and to use it to inform and improve building design, building construction, and building operation, and to inform future designs. Such data can be used to create intelligent buildings that can shut down unnecessary systems as and when they're not being used. They can use it to open and close louvers or windows to deliver optimum levels of air or natural light. And even technologies like RFID sensors are being used now in the construction industry, particularly in the manufacture of prefabricated buildings, where it's quite complicated and complex when you come on site to put together a complex building from prefabricated parts. But by embedding RFID sensors, you can use those to track the pieces, to plan the installation of them, and then use that data automatically to update BIM models so you have a real-time picture of how the building's progressing. So I'm looking forward very much to hearing in more detail the expert speakers who are here today to talk about these and other uses of future technologies in the construction industry. And I would like, first of all, to invite Dr. Yanis Brilakis from the University of Cambridge to the stage for our first talk. Thank you.
So good morning from me as well. I think I should be standing here, right? Many thanks for inviting me and many thanks for the introduction. My name is Yanis Brilakis. I am the Langeroog leader in construction engineering at the University of Cambridge, in the Langeroog Center there. What I've decided to present to you is just start first with a little bit of a background of the environment that I'm working in, and then work on top of that to tell you all the latest and greatest in the research that we're engaging at the University of Cambridge, exactly in the space of the workshop today. So starting with the environment, not sure how much you know about the University of Cambridge. It was founded in 1209, granted royal charter by King Henry III. It's the world's fourth oldest university, with 31 colleges and over 100 academic departments organized into 6 schools. It operates Cambridge University Press, which is the world's oldest publishing house, 8 museums and a botanic garden, and our libraries have roughly about 15 million books. The university has, I think, an annual research income of about £2 billion, and together with the colleges, it has a combined endowment of roughly £6 billion, making that the largest outside of the United States. It's consistently ranked within the top 3 or 4 universities in the world, both overall as well as in various subjects. You can see here in the slide some pictures from the university, Corpus Christi College, King's and Trinity. The picture you see there at Trinity, that tree is a direct descendant of Newton's apple tree. I don't know if you remember that story. Speaking about Isaac Newton, the university has educated many notable alumni, including eminent mathematicians, scientists, politicians, philosophers, actors, and heads of state. Examples include Charles Darwin, Niels Bohr, Alan Turing, George Stokes, John Harvard, John Maynard Keynes, our recently departed Stephen Hawking, and many royalty like King Edward VII, King George VI, Queen Margaret of Denmark, and so on and so on. Overall, 98 Nobel laureates, the most of any university in the world, as well as 15 British prime ministers and 10 Fields medalists, have been affiliated with Cambridge at some point in their careers. But of course, the most important thing is that we beat Oxford in both the men's and women's boat races this year, and we like to make that point every time we present. Having said that, and going into more specifics, the Department of Engineering at Cambridge integrates all of engineering divisions into a single unit with a single undergraduate program. The Civil Division sits within the National Center for Smart Infrastructure and Construction. And you can see here not the actual building, but the building that will exist about a year from now. Right now, it's still in the construction phase. The Construction Information Technology Laboratory is part of the Lemberg Center, which is within this division, and also affiliated with the Center for Digitally Built Britain at the University of Cambridge. But enough about the introduction, let's move on to the research. I think most of you in this room are familiar with the productivity problem in our industry. Construction is outperformed by just about all other sectors of the global economy in value added per man hours, which leads to substantive value lost across the globe, and particularly in developed economies. Of the 4 key trends that can disrupt this phenomenon, only one is technical. I think you can see it in this slide. Yes, I think it's shown. Basically, digital technology, new materials, and advanced automations. The question, though, is how can we exploit these kinds of technologies, the digitization and the automation, without first digitizing our processes and our products? Construction as a sector ranks near the bottom of all industries in terms of digitization, and that's because it is at the very bottom of everyone in terms of data stored. We basically lack the means to cost effectively generate and exploit the digital twins, let's say, of our assets, which is why only 2% of the existing building stock even has a design BIM model, and even less for horizontal infrastructure. This is the kind of problem that we're trying to address at the University of Cambridge. And to be more specific, we aim to generate the geometric digital twin of infrastructure, enrich it with structured and unstructured data, and exploit it to improve design, construction, and operation processes. I have an example here. Let's say I want to digitize this asset. I want to first of all go there and somehow, with drones like the ones you see in the back or other technologies, automatically scan it and get the points and the pixels. Once I have the points and pixels, I then want to convert them automatically to BIM objects with relationships, create a geometric BIM file. And once I have that, I want to add the real textures on top, detect and measure, for example, things like visible condition data, and then assign them as properties to the object with little or no human effort in the process, so that I can then exploit this output. Let's go through these steps and let me show you how we do that. Step number 1, getting the points and the pixels. This is some work we've done quite a while back when we started first using laser scanners and other equipment like that. we were very disappointed in the time it took to get the scans in place, as well as the fact that I had to do all the post-processing stitching afterwards. And we really thought there has to be a simpler way to get the outcome. So we developed back then a method we call mid-range mobile videogrammetry that basically allows you to get your mobile phone out, scan a building, a bridge, any asset from about 25 meters away, and get a point cloud with a spatial error that is sub-centimeter. Now that's not as good as a laser scanner, but for most applications, that's pretty good, considering that it comes from just an app on your phone. This is now patented and commercialized in the US through a company called Pointivo. The outcome of this looks like this, and then we have methods to equalize the densities, fix the holes, and so on, until we give you a nicely looking point cloud in the end of the process, with the textures on top. The reality, though, is that people don't like to play with this data, because this is what I call dump points. Okay, this is just points. Engineers prefer to work with objects, prefer to work with something that's more higher level in the design process. So our next target is, okay, I have the points, but how do I convert them to this? And this is actually a much, much bigger challenge. It's a bigger challenge, just to give you some data that's actually well publicized. First and foremost, because for every 1 day of scanning, the person who does the modeling job has to spend 10 days. This 1 to 10 relationship shows the magnitude of this problem. The other problem is that we're looking at point clouds with, in many cases, over 30 billion points. We don't have a computer today that can open that file. I have to process the results piecewise and then stitch them together somehow in the end. The result is examples like the one you see there. A small reactor building, 40 billion points. It took 10 people 6 months to finish the model. But most importantly, this is the most boring job in the world. Because you have to go there pipe after pipe, valve after valve, column after column. So clearly this is a case that screams for automation. So we started looking into that by working with simple methods to detect, for example, a column from a webcam in a laptop. Long story short, zoom in 10 years later, now we have the capacity to go and scan a bridge, and from the scan of this facility, I apologize for the stuttering, this is the problem we discussed about having 3 monitors before in the system. But once I have that scan, I can automatically get the objects that you see in this video. And we can do this for real bridges with real problems. By the way, no bridge is straight. Okay? Every bridge has all kinds of skews, every object has all sorts of peculiarities. The world, the real world, is much more complicated than the design world. And my point is we've been able to capture those peculiarities and give you very good models in the end. We basically start from that, get all the objects, and give you the model without a person in this process. Once I have this model, the question then is, what do I do with it and how can I benefit from it? One example is using technologies like augmented reality and virtual reality, which can allow us to bring these models, for example, into the office and allow a person to walk through this model and basically do, if they want a bridge inspection, without leaving the office, okay, with the real textures, the real problems. Another example of application is in the VR space. You can see here a student inside a Cyber virtualizer wearing the HTC Vive, walking around the bridge and doing a bridge inspection the same way they would as if they were on site. Once we finished the bridges project, we then moved on to more complicated cases. And by the way, by more complicated, I'm referring to the fact that in bridges everything is exposed, the number of object types is very limited, so for us that was the low-hanging fruit. Once you go into buildings, in buildings we try to hide everything. We don't see all the objects. Many objects are only partially visible, so we have to assume what's behind. Inference starts playing a big role. To make that possible, we worked with several other universities, Stanford, Georgia Tech, Technion, and others, to formalize the digital twin generation process by employing a little bit of machine learning, several deep learning strategies in particular, to go from the point cloud and start gradually segmenting it into the components. So we go from the whole thing to the floors, from the floors to the rooms, from the rooms to the walls, floors, ceilings, and gradually get down to the level of detail of interest. This is what you see here, detecting floors and ceilings at the presence of clutter, detecting walls, fitting components, and creating the actual BIM file automatically, and so on. Again, same question. Now I have my as-is model of my facility. What can I do with that? Again, several examples. We've only explored a few. One example is the one you see here. During the construction phase, can I take my model with the design data, with the schedule data, and overlay that on top of my actual construction site? My office is right there, by the way. This particular case that you see in this picture, the BIM file you see is schedule loaded. The components that you see were supposed to have been built on that date. So now that I've told you that, you can see that the project's behind schedule. It was in fact behind schedule by 9 months. By doing that superimposition, we can automatically now do a simple volumetric comparison. Is there a column where I expected? Yes or no? If there is, great. If not, I mark that as behind schedule, right? And by doing that, give you this in one go. Now, all the progress inspector has to do is walk around the facility, make sure they see all the components, and the progress data will be automatically updated inside their BIM file. Another example in the case of operation and maintenance is bringing the same type of file, and again, I apologize for the stutter, it's a graphics card matter. You're welcome to test, by the way, any of these examples using the HoloLens later on. I have them all preloaded here. So again, this is the case of being able to go into a building, bring in the BIM file in front of you, allowing the person to walk around, click on objects, get maintenance or operation information, or provide back information if you are an inspector who just finished an example. But of course, geometry isn't everything. Geometry is one part of the puzzle. Once I have it, I then need to add a lot more information to it. And one of the types of information we've been working on is condition data. We've done a lot of work on detecting all sorts of problems, spalling, corrosion, cracks, exposed reinforcement, and so on. But once I have this information, it only brings me value if I can link it directly to the model, place it in the right position, measure it, and assign those measurements as properties to the component. So now I can automatically click on that element and know that there is a flexure or crack with that length, that width, in that position, with that orientation. Again, without human input in creating that data set. We've done the same thing for roads. And the example you see here is the example for the case of roads. The difference is we've used different types of sensors. In this case, we use your parking camera. So as you're going to work, I can use your camera to capture the cracks, the patches, the potholes, all kinds of problems, measure them, and once I get those measurements, send them to the local council with an obvious request to go and fix those things. Imagine if you crowdsource this. Imagine if every car had the ability to use their parking camera to do this. How much more efficient monitoring of road condition can become as an outcome. And we're having discussions lately with Volkswagen to make sure that their next generation of cars includes these kinds of technologies within their vehicles. And you can see here exactly the process I just discussed. Another example is the case of integrating sensor data. I have a lot of colleagues at Cambridge who work on infrastructure sensing. You sense the infrastructure, you get a nice squiggly line. What do you do with it? How do you link that data back and make some sense out of it? This is where the value comes of linking the sensor data to the model, so you can better interpret what it means for the asset. To make that possible, we created an IFC data model extension that allows you to put both the sensors on the components as well as the sensor data. This is because what we want to achieve is what we call the live digital twin. I don't just want an accurate geometry, I want my asset linked to the real thing, feeling what the real thing is feeling, and allowing me to monitor what is actually happening to my asset in real time. And we've been working now for a number of years with Crossrail and Network Rail to deploy this over time to their entire asset base. Moving beyond that, I'll just show you a few more examples of exploiting digital twins and these kinds of technologies. This is one project we've done together with Len Waruk and Tony G, a bridge designer. In this case, we looked at how can we bring basically digitization into the DFMA process designed for manufacturing and assembly in the case of bridges. This came at the advent of the High Speed 2 project, at the time where we're looking at 300 new bridges were about to be built. What's common about these 300 bridges? Well, none of them are iconic. None of them are anything special. You want to build them on time, on budget, with maximum certainty. And this is where the value of the DFMA comes along. Although the process that currently exists for delivering bridges is really built for the bespoke process. What we did then is we looked at the entire process from beginning to end, from the very early phases of route alignment all the way to a delivered bridge. We mapped out all the decisions that have to be made. We mapped out the data that you need to make each decision. And using that, we linked them all and reoriented them so that every time you make a decision, you have exactly the data you need to make it reliably. For example, we moved the choice of crane much earlier on in the process because that tells you how heavy your components can be as you're trying to design bridge beams and other things that you have to bring on site. The other thing we did is now we had all the dependent and independent variables in the system, which allowed us to create all those red arrows that you see in this case. These red arrows created for us a unique, what I call design automation system that allows us to open a Microsoft SQL Server application, sit together with a client, ask him exactly 16 questions. If anyone can guess, the number 16, that's the number of independent variables in your typical highway overpass. That's the only things you can influence. Everything else comes from the codes of practice. Once I get those 16 answers, I can click one button and automatically get the final design. That process would typically take Tony G about 7 weeks to finish manually. Now they can do 3 of these in 2 minutes. That's a big advantage of design automation. Another example, we've employed these types of technologies is to bring the models to the workforce and allow workers to build using the digital twin from the design phase all the way to the operation phase. For example, in this case with reinforcement, have the reinforcement superimposed on the real thing and allowing people to inspect what's missing, what's not there, or allowing a worker to build using the 3D as opposed to the drawings. Another application is relevant to productivity. In a prefabrication factory, like in the case of Langeroog, the Explore Industrial Park at Stigley. We want to be able to monitor the procedures that are happening inside the factory and link that back to the model. Imagine that I have my digital twin, I have every component there, I allow a worker to tell me, now I'm about to start on working on this component, and whenever they finish, tell me that component is done. If in the meantime I've been able to use vision tracking to capture their processes, I can then measure the number of cycles they've been able to do during the time of building a component, and then measure that productivity and understand what is wrong with my process. I can also see when production has stopped, so I can take early and quick decisions before I fall back in my schedule. One of the last examples I want to mention is in the case of robotic teleoperation. How much do you know about robotic teleoperation? This is actually an old topic that's existed for a long time, just hasn't been very popular within the construction space so far. The video you see in the bottom is from the well-known movie Real Steel with Hugh Jackman. Has anyone seen it here? Anyone? I can see some people nodding heads. So what Hugh is doing in this case is that he's pretending to be a boxer, but he's actually not doing any boxing, it's the robot that does all the work. When I saw the movie, the first reaction I had is, well, why a boxer? Why not a worker? Why can't we capture all the motions of a worker? Have him remotely control a robot and let the robot do the heavy lifting. This is the robotic teleoperation process, and it's the loop you see up there from motion capture all the way back to haptic feedback. We've done a simple example of that, which I want to show you here, and highlights exactly that these things are coming up. Maybe not next year or the year after, but you should expect to see these types of applications coming within 5 to 10 years. What you see here is a student standing in the back, remotely controlling this virtual robot, putting bricks in place, picking up a spade, placing some mortar, another row of bricks, picking up a hammer, aligning those bricks, and so on. Doing a typical, bricklaying tasks, all without ever touching at all any of these materials. I'm now working with a colleague of mine in evolutionary robotics who wants to take that a step further and take those virtual instructions and move them to an actual robot who can do the real thing on the field. I was also asked to present a small case study and focus on one particular topic a little bit more. I chose to present one for which we received an award at the Construction Research Congress a couple of weeks ago. I have a small video. I'm not sure the sound is going to play this one, but let's try. Can anyone hear anything? I guess that laptop in the back, of course, cannot go all the way to the front. So I'll skip the video and just present the topic myself. That's the problem if you have too many videos. Things will go wrong. One of the topics that a lot of bridge owners have that many of us are a bit oblivious to is the problem of bridge strikes. How many of you know that in the UK there is one bridge that is hit every 4 hours? Every 4 hours. And the bridges that are most commonly hit, the low bridges, get hit on average once a week. Okay? This is a real problem that I guess most people in the general public are unaware of, but the actual bridge owners have issues with. Not only because you have to keep repairing your bridges that get hit all the time, but also because, let's say it's a rail bridge and you have trains passing on top, and this is a major hit that has moved the tracks and can derail the train. You need to be able to know about these things very quickly, know the severity very quickly, and be able to react very quickly as a consequence to that. This is related to asset protection. Okay, how do I protect my asset from anything, in this case, toll trucks? There are technologies, like the one you see here. In the Dartford crossing, you can see that laser beam. Anything that crosses that laser beam will tell the system that an overheight vehicle is approaching, will give a personalized warning to that vehicle and allow it to exit before it's too late. But I'm not sure if you can see the problem in this case and why this setup only exists in maybe 3 bridges in the UK. The problem is this. It's the permanent infrastructure you have to install. To put that thing in place in both directions is worth about £250,000. The reaction from clients is that I'm not willing to pay that amount. I'd rather let my bridges keep getting hit. It's as simple as that. And this is not just in the UK, it's the same in the US with several clients we've spoken to. So they're looking for something that will give them that functionality, but at a much lower price. So what we did in that case is we first of all tried to understand the end user requirements. In this case, I want something that's less than 20K, that will give me early warning detection, relatively accurate, capture the number plate, and then report that collision in real time and link it back to the digital twin of my asset. And the way we've done that is with the system you see here. I have a single camera placed upstream on the traffic. That camera is positioned in the way that you see, and it is positioned exactly at the overheight plane. Now, if you think about that for a moment, if your camera is exactly at the overheight plane, that plane appears in your view as a line. Once you calibrate your system, anything that crosses that line is overheight. But at the same time, from that same camera, I can capture the license plate as well. And I can record the collision if necessary. So what you see here is the 3 parts of the process. Warning, to give them a chance to exit. If they don't, detection of the hit. And we've already recorded the license plate during the warning phase. And then reporting that hit back to the digital twin. And this is some examples from our deployment that we did at the Fairlock station at London. You see our camera up there. That camera is linked to traffic, and you can see the overheight region that we're looking at. Anything in that space we are detecting, understanding that it is in fact the vehicle and not a bird or a tree or something else, and then from that giving back a detection with a height error that's well within the tolerance we were given by London Underground. Again, you can see the traffic here. I'd like to stop here because I know you have a long day and just acknowledge that I didn't do the work. It's those people in the bottom that have done everything, and the people in the top that pay for it. And to thank you all for listening to what I had to say. Any questions? No questions? Okay. Yeah. First and then second.
Me? Go first?
Yeah.
Okay. Yeah, I thought it was super, really, really interesting, and really enjoyed it, and delighted where we can take all this technology and all this data. But what are we doing with the people when we replace them with robots?
I don't think we are exactly replacing the people. What we're doing is we're helping them be more efficient and focus on the more let's say, brain-stimulating tasks rather than the brain-dead tasks. And I think that that's exactly what happened if you think back at when the first construction equipment, the first excavators came in place and replaced people digging with a shovel. We kept employing those people, only now they were a lot more productive at what they're doing, and now that justified giving them more money. So wages went up. And I don't think we lost any jobs, because what happened is that with the advent of equipment, we just had more projects. We could do more things. So all those shovel diggers, I think, eventually found jobs as equipment operators.
So if I'm immersed in this whole digital world, or actually we're using it in reality, how can a robot or something like that take, or how can they be aware of maybe other risks that they don't see that a human being can see? I'm trying to see how this transfers onto real construction site.
Well, the thinking is that the robot is, in this case, completely dumb. Okay, it has no intelligence at the beginning. It sees what you see, and basically you have full control of it. If something goes wrong, at least you are not there. It's the robot that gets damaged, and not you. In the long run, and this is perhaps something I didn't mention, the long run vision is that, well, if it takes me 10 hits with a hammer to put a nail in, maybe I don't have to do that simulated motion 10 times. Maybe I just need to do it once, and then the robot figures out, well, I need to keep doing this until the nail is done, right? And then same thing with a screwdriver, and same thing with something else. Basically allow people to progressively train using machine learning a robot into doing basic tasks, so that they have to physically do a lot less to produce a lot more work.
Okay.
Sorry, there was a
Same
question
thing.
back there.
You spoke about scanning more complex structures where you couldn't see all of the objects that you were looking for, and you said that the next stage is inference. Is it the software does the inference, or is there a person involved in that stage? How does it work?
So this is where machine learning goes in and helps us understand basically the nature of buildings, what we call engineering or architectural priors. The simple example I was trying to explain is that if I know I'm scanning a building, I can make a fairly safe assumption that a building might have floors. So let's find those floors first. And it's easy to find out the floors and segment that space in between. Once I have a floor, it's a very safe assumption that a floor has rooms. And what is a room in a point cloud? It's a big empty blob. So I direct my system to look for big empty blobs. Once I am in a room, again, I can make a fairly safe assumption that most likely there is a ceiling, and most likely there is a floor, most likely there are walls around it. I think you get the point. You can gradually apply that thinking recursively, many layers down, all the way to the doorknobs. And the point there is that it makes the assumption that you're not going to find a door in the middle of the room. It has to be in line with one of the walls. Now, is that always going to be right? No. But if I can get 80% or 90% of the work done this way, and then have a person come in and fix any peculiarities or special components and so on, I've achieved 80 or 90% of the solution. Yeah. Anything else? Any other questions? Yes.
Would you think AI is a solution for all the statistical process from robot control?
In my experience, generally the space of machine learning is very good at very, I would say, trivialized problems, simple problems that are repetitive. So if you have something that is a high-level task, AI is very far from being able to do that bit reliably, okay? The wisdom bit. But if you're looking at making very simple, very quick decisions that are repetitive, like the example of modeling lots and lots and lots of pipes or lots and lots and lots of columns, these are very, very clear cases where AI can be a big win. All right, thank you very much.
Thanks very much, Janice. That was extremely interesting. It's good to get a few questions to test you out. We're just trying to get your presentation linked up because we had it switched to Janice's. That's something we.
The same computer.
Okay, well, somebody's working there in the background, so we'll push on and we'll get David up. Let's just introduce David Clark from McAvoy Group. And David is heads up the innovation manufacturing aspects for McAvoy, and he's going to be sort of supported by an associate of his, obviously, Hong Kwan. And between them, they're going to give us an insight as to how McAvoys are embracing the whole sort of modern technologies within their processes. And you get a chance to sort of maybe even speak to them afterwards, anybody that's interested. But they are specialists in off-site construction, and they're doing quite a bit of work in the UK generally, and they're becoming very, very successful at it. So we're interested to hear how they're using and embedding these technologies to advance their process and their business. And as soon as we're up and running, I'll stop talking. Future technologies. If only we could work with the crowd. Give me a sec.
Stephen, can I ask Janice a question then, while we've got time?
Yeah,
Janice,
sure.
would you suggest then, if we're teaching people how to build bricks, that's the wrong thing that we should be doing as a college and in university? Should we be challenging what the students are learning?
Very good question. I was just actually having that discussion earlier with one of the colleagues here. We have the same problem at Cambridge. A lot of people keep teaching old school traditional structural engineering, geotechnical engineering. And you see people finishing up with a PhD in structures from Cambridge and getting a job in London for 30K. At the same time, I see my students who learn more computer vision, machine learning, and how to apply it to the sector. They wouldn't even consider a job less than 100K. And this is the same degree, right? Same age, same types of people. And I think this has to do with momentum and the inertia. We've learned to be teaching those same things over and over and over many, many decades. Obviously, the people who've been immersed into that environment love their job, they want it very much, and they enthuse all the young people. But the problem is they enthuse the young people to something that's technology of the past, where we don't need as many people, whereas in these new spaces, there is a huge demand. Another example I can give you, just yesterday I had a chat with one of my PhD students who's considering whether to do a startup or to get a job as a computer vision technical lead in a company in Germany. And he's telling me every job I apply to, I'm the only candidate. There's no one else. Anything I ask, they offer me. So then he's thinking, what if I was that guy? If I do the startup, I won't be able to hire anyone. I will be just as much starving as all these other guys for people in that space. So why don't I use my advantage and go work for someone else? Exactly because this is a basically a buyer's market rather than a seller's market in that type of environment.
That's a good info.
Thank you, Janice. So I think we've got our IT issues sorted out. So welcome everybody. Yes, my name is David Clark. I work for the McAvoy Group. I've been in the construction and manufacturing industry now for about 20 years. Originally started off studying manufacturing management. Worked across a number of different sectors in the composite cladding, rain screen, heavy engineering, railway bridges, lift shafts. In the last 6 years, I've moved into the off-site construction industry, where I've really been able to follow this sort of digital journey that we've been on and lead us through this BIM journey that we've been going through, and led me to sort of do some study in a Master's in BIM and Project Management down at Queen's University. So today, I want to sort of tell you a little bit about McAvoy Group and the off-site construction techniques that we use to deliver our buildings in this changing world, and how we want to actually address some of the productivity issues that Yanis was sort of pointing to at the start of his presentation, and just explain a couple of case studies on how we are using some of these digital technologies and applying it to real projects. So a little bit about ourselves. You know, we are a family-owned business, and we've been around for about 40 years now. We have 2 manufacturing facilities in Northern Ireland, delivering 120,000 square feet of manufacturing capability. We're very digitally minded. We were the first to achieve BIM Level 2 certification from BRE Global in UK from the off-site construction industry. We've embraced VR, AR. We won an award last year for our implementation of that on a particular project. So digital is very, very much part of our business, and we see it as the future. Our vision is very much to be the partner of choice, delivering off-site solutions within the UK, and delivering quality solutions along that way across a number of our chosen sectors. Early engagement is key to us. From an off-site perspective, lots of decisions happen very early in the process. Therefore, we are engaged with our clients and our customers and our users in respect to our education facilities at a very early stage in the process to get our buildings right. Therefore, these digital technologies that we're looking at and seeing and demonstrating today allow us to bring those user base and clients right into the process right at the start, and get really good decisions, fast decisions that make a difference to the project. I've talked about BIM, and I think a lot of people have heard this three-letter acronym an awful lot over the last number of years. From the company's perspective, their journey started a very long time ago. They've been using some of these digital authoring tools right back as far as 2007. I think personally I've been using a lot of these three-dimensional authoring packages and tools even a lot, long before that. So long before this BIM was being talked about, it was still being used in the manufacturing and the construction industry. It's just been focused on more recently. And certainly we had the insight from the business leaders to say, go and get yourselves ready, David. Make sure that we are BIM Level 2 ready. So we set about a plan, and we achieved that plan. So we got ourselves the certification back in 2016, re-audited last year, and just about to be re-audited again. So the BIM processes are embedded in the business, and we feel we know them, but we still learn, and I have to look to the future as to what new technologies are coming down the line. We have got a KTP associate with the business at the moment. This is Hung, who you'll hear from shortly. He is helping us, keep at the forefront of that, and looking at these technologies and making sure that we really implement them and embrace them as much as we can. So in respect to our BIM processes, we've always had this open BIM philosophy. We use lots of different authoring packages within the business ourselves, but we also work with a lot of consultants externally to us. There are a huge number of digital authoring tools in the construction and manufacturing industry. So for us, the information sharing has to be in a standardized format. And I think that's all that slide is really showing you. When we get our three-dimensional models, they are in standard file format of IFC. And then whenever we review those standard file types of IFC, we communicate back to our design team using BCF or BIM collaboration format. So these standard file types, we use PDFs daily. This is just a three-dimensional version of PDFs to allow us to communicate our designs and our issues throughout the project. We have a common data environment. We must have a digital cloud server to actually share all of this information. We use Viewpoint for projects. We're able to graphically show all of our information up there, put our information planner up there, and tell everybody what we want and when we need it in the project. We can tell everybody what their roles are in the project. And of course we can view the 3D model, but BIM is about much more than the 3D model. It's about the processes of how you deliver that particular project. So these digital tools actually allow you to adhere to these processes along the way. COBie is something that is there, and if you're delivering a BIM Level 2 project, you must be delivering COBie, which is the data behind the 3D model. The 3D model is a dumb element if it does not have the data behind it. So in the background, you must be able to handle this and actually manage it, because whenever you hand your digital asset over at the end of the project, without this COBie data in it, it's not much use to the facilities management team. So this BCF that I mentioned earlier, well, what does it mean? So this loop is showing you that you use lots of different authoring packages, such as an architectural package like Revit or ArchiCAD, to create your digital buildings. Once you do that, you save it as a standard file format or an IFC, and then as the main contractor, it is our job to actually review, validate and check those 3D files. We can't assume that the designers are just going to get it right. We must check that. So we take the standard file formats, we bring them into a software package such as Solibri or Navisworks in the Revit world, and we take these IFCs, we federate them together, we overlay them all, and we check them. Did we get what we asked for? And if we didn't, we must tell them what's not right and what needs to be changed and what needs to be resolved. And we do that through the standard file format of BCF. All this does is it provides them a file that they can import into their authoring package. So instead of giving a designer a long list of items to go and fix, we give him a file. He can import that into his authoring package, such as Revit or ArchiCAD, and then he will be able to click on each of the items that we found, and it will take them directly to that in the 3D model, with a story that we've told them that's not, what's wrong with this, and then they can communicate back in that same format. It's a nice 360-degree loop of communication using standardized file formats. Here's a project that we delivered probably about 12 months ago now. It's a £20 million plus project. So whenever people think about the off-site construction industry, they very much have this temporary building vision in their head. The old temporary classroom you might have had to go to school in. Things have changed. We're delivering permanent buildings. We're just building in a slightly different way. We're building in a more efficient way using off-site construction techniques. And these allow us to provide these fantastic buildings. So that's what this slide is trying to just get across to you, that these are not small buildings that we're delivering. Another building that we've delivered is, this is West Hill. So this was a special needs school for Surrey County Council. And it was particularly challenging because we had a very constrained site. And that we had to work around these sort of challenges to deliver the building. So if we look at the site, all of the grey buildings that you see here are existing buildings on site. So what we did was we went out and we took a point cloud survey, because between the building was L, the new building was an L shape. So between point 1 and point 2 here, we had a fall of nearly a metre between these 2 points. And so we had to design, construct our new building and take account of these, where we're going to have these 2 touch points in the existing facility. So we're taking our point cloud, creating that into a 3D model, gave us a very good starting point to be able to wrap our 3-dimensional new building around to ensure that we got this right. It worked very well for us, and it's probably an area that, the scanning technology, which is some of the fantastic stuff that we were seeing earlier, we need to look at and see how we can embrace that a little bit more within the business. That particular building was, I think, it was 28 modules. So when I talk about modules, these are large volumetric sections of the building that we construct in our factories. These volumetric sections can be 4 meters tall, up to 3.5 meters wide, and up to 16 meters in length. These are large sections of buildings. And we have 28 of these in this particular building that we manufactured in a factory in Northern Ireland, put in lorries, boats, take them down to the site, and then put them together again. Of course, we use these technologies to help us along the way. We were allowed to do clash detection, resolution, walkthroughs with our clients. This client engagement at the early stage allowed us to achieve an awful lot. We were able to get the building into manufacture very soon after our contract award, because we've done a lot of upfront client engagement. So the feedback from our clients and the school is just that we had less disruption on site because we were there for a shorter period of time, and that's the key thing for us. Everybody thinks that off-site construction is actually going to be a cheaper form of construction. It's not necessarily the case. We have to deliver to the same specification as traditional means. The key point for us is that we can have concurrent activities happening. We can be on site doing the site infrastructure whilst we're manufacturing the building in the factory. So we can cut programs by up to 50%. And that's why we do an awful lot of education buildings, because school shuts down in summer, they won't come back to a brand new facility in September. As a business, we're also looking at housing. So there's a huge housing shortage across the UK, and how are we going to address that? Well, modern methods of construction or off-site construction is being projected as being a means and way of actually being able to address that. It's probably not the silver bullet, but it'll certainly help address some of that. So we're looking at that as a business. The house that you see here has got 4 modular units to construct the house. So within a couple of days on site, you can have foundations to house completed. The very fast means of construction on site, because a lot of it is done in the factory off site. Of course, we're using the technologies, because here's the light gauge steel frame and been modelled, translated into the actual steel frame whenever we bring it into the factory. So we take these flat packed frames, create these 3-dimensional volumetric modules, hidden surfaces to create a finished building. So again, it's a new technology to deliver this sort of old traditional type of building. So in this digital age, things are changing very, very fast. We're very aware of this, I think we're an exponential rate of how things are changing. Certainly in the 20 years I've been in the industry, things have changed dramatically. And to put this across, I was at a lecture down at Queen's by Dr. Bettina von Stam, and she said it took 75 years for the telephone to reach 50 million customers, 38 for the radio, 13 for the TV, 4 years for the World Wide Web, 3.5 for the iPod, for Facebook, 3 for the iPod, but 35 days for Angry Birds app on your phone to reach 50 million customers. We live in a really connected digital world. So if we don't embrace this, it will pass us by. And as a business, we don't want that to happen. So we've been looking at some of these technologies, which are here in the room today, which is great. So we've got augmented reality. So we're overlaying the digital world onto the real world around us. So you can still see the world around you. We're just overlaying some of this digital information. We've got the Daiquiri Smart Helmet up here, which is effectively a hard hat with a computer on it. Very similar to the HoloLens, except it's 3 times the price. It's near £15,000, I think, for one of these units. Probably not going to be many of those around too many building sites just yet. But the HoloLens, it's sort of 3,500 to 5,000. Better technology, in my opinion. I haven't tried both, but probably still not quite there yet. Very useful tool, but it will get there very, very fast based on some of the previous slides I just showed you. But you can also deliver this technology through phones and tablets. For us, what's this about? It's about being able to actually take all of these digital models that we've been creating for years now and actually delivering this straight to the front line. So we create a 3-dimensional model. We have these fantastic, coordinated, data-rich pieces of information. We then go and we translate that into 2-dimensional drawings, and that's what we construct from. So we're going back to 2D paper drawings to actually construct from. If we can cut that wasted process out and take this digital model and deliver it straight to the frontline workers, either in the factory or on site, then that's going to be a huge gain for us. Whether it happens today or tomorrow, I don't know. It's going to take a while, but it's certainly possible with some of the technology that's out there at the moment. So I came across a company in America, Martin Brothers Construction. So they ran a proof of concept using a HoloLens. Could they create and manufacture the steel frame for a bathroom pod purely with the HoloLens, no drawings? And they did it. They were able to overlay the track, set the metal track down on top of the holographic images that they saw, and cut it with no measuring tapes, no drawings. So proof of concept shows that it can be possible to do this. a lot of talk by the previous presenter about augmented reality and how this can be used right across the life cycle of a project. I was at the Digital Construction Show last October, I think it was, and this term of the augmented worker was being bandied around, how we're actually going to be using this technology out on site. If we go out on site, it will highlight unsafe zones for us. It will highlight how we're doing against program. So this is certainly going to start impacting us more and more over the coming years. We have some links to the Manufacturing Technology Centre over in UK, who are one of Innovate UK's 6 high-value manufacturing centres. They're doing some fantastic research of how they can bring augmented reality into construction. They've done this for the automotive and the aerospace industry, and they're now saying, how can we make this work in construction? So we're part of that project with them, and it's interesting to see how that develops over the next while. So VR is a space that we've been in since the start of 2017. It's a different technology, it's a more immersive technology, which again you can try yourselves today. So we've been trying to see how can we leverage that as a business tool. So for us, it's not going to replace our BIM processes. What it does is it adds something new. It's a new dimension to this. It allows us to visualize our buildings in a different way. When we looked at this, the solution that we wanted to bring into the business had to be a business tool. It had to provide added benefit to us. So we needed to get into VR very quickly from our BIM model. So I call this one-click VR. If I had to go and do a lot of post-processing or a lot of extra work to get into the VR environment, my designers just wouldn't go there. It just wouldn't be worth the effort to get into it. However, the solution we have now, we can go from a Revit model or an ArchiCAD model straight to VR at the click of a button, which means that we can just visualize our building in a different way very quickly. It also has a bi-directional link from the CAD model to the VR environment. So if we have somebody with a VR headset on, we have the designer sitting beside them in their actual CAD authoring package, making changes which can be seen real time in the VR environment. So real-time design can happen in the VR world direct to the designer. What you will see, however, with these systems that are here, they're very singular. You put a headset on, you're very immersed, and as such, it's almost counterintuitive to this collaborative environment that we've been talking about in the BIM world for a long time. So for us, we had to have a multi-user solution. The solution we have allows us to do that. We can launch a VR session from our designer. They can basically then invite our client or our user base who are at the other end of an internet connection with a headset and join that. So we can have multi-users join our VR sessions and we can effectively tour guide them around our building remotely. So this is bringing this collaboration back into the VR environment. And I think the VR world probably needs to do a little bit more work to make this a better experience, but we can do it right now, and it's important for us to be able to do that. We also want to see how we can actually use this to help train our manufacturing staff. It is a very immersive and a real experience that you can have whenever you've got the VR headsets on. The technology's got that good. So we've had quite a few sessions with our manufacturing staff, bringing them in, letting them see this technology, letting them try it, and they quickly realise how real this can be. So for us, we work in a manufacturing environment. We do lots of repeatable process, and if we can build experiences which mimic those processes, we can train them in an offline and safe environment using VR, as opposed to putting them out on the front line and learning on the job. Augmented versus reality, the two technologies, and I looked at a little bit of the research. I think VR has been taking a little bit of a front run on augmented, however I see that's going to change. I see augmented starting to embed itself a little bit more in the construction world over the next number of years, simply because I said earlier that phones and tablets can deliver augmented reality. Everyone has a phone, a huge amount of us have tablets, and they're being used more and more. So if that's the medium that we can get augmented reality out to our workforce, it's going to happen a lot quicker than some of these other VR headsets. VR headsets are not hugely expensive at this point in time. I think from £300 to £500 probably get you a good headset. However, that's still a purchase point. There's a decision to be made, will I go and spend that money? And people don't want to do that until they try it. So people have to try it before they buy it, and that I think is going to be a bit of a stumbling block to actually get this out there. So the challenge ahead is that this digital transformation is happening. We have to get on board or we will miss it. So we're very much at the forefront of it. And in the MACE report that I'll highlight here, they're showing that this will impact our workforce. 600,000 of our workforce need to be upskilled again for these digital technologies that we're talking about and exhibiting here today. I think some of the universities and colleges really need to embrace this and start embedding it into the courses a little bit more. Because I think at the moment a lot of the new students who are coming out are really starting to learn this stuff on the job, in the commercial world, whereas it can be brought back a little bit into the teaching and training. So we've been working a little bit with Southwell College over the last 6 months. We've been working on a VR project to help us deliver a slightly better experience through this VR technology. Some really good results so far that we're sort of showcasing today. And we're certainly like to continue that, and we've been talking about how we can actually further that collaboration and seek some research in this augmented world where we see the sort of future heading towards. So that's me, and thanks very much. I'm not sure if we'll take questions now or later.
We can take a few questions as long as they're quick questions that require short answers, because we are well behind as it stands, but don't let that deflect you.
I'm here all the rest of the day, otherwise.
Happy enough? Perfect. Thanks very much. Okay, thanks very much, David. I don't know about anything else, but we've been working with these guys for the last maybe 8 months, and that still even sort of surprises me to the level that you're actually sort of working on currently. And there's still a lot for us to learn from you, and hopefully we can actually input something back into your business, as you say, with a few projects going ahead. I'm going to invite Hung up to maybe take that a bit further. Hung, as David said, is a KTP associate with McAvoy Group, and I've sort of put you down as a technology researcher for them, and so don't make me a liar. Good man.
Hello. So just in the meanwhile, they need to get prepared for the presentation. Just introduce myself. I work between McAvoy Group and Queen's University Belfast. And so I did my degree in Queen's University, and my first job I decided to do KTP project. The aim of the project is investigation in digital construction for McAvoy, and also even myself, I used to work as a placement in a consultant in Belfast. As a young person, I see that there's a lot of people still do 2D drawings. And when I see the wood beam go to digital construction, it is something a kind of touching me. It is something I see that is the future of construction, that we need to move faster and use better technology. So I have an old picture of the construction industry, and I believe that still a lot of people still think that is a construction industry of people do heavy duty work, difficult time on site, and nowadays, as we mentioned before, robot in construction is dull, and I see the same picture that it is something to make people's life easier. All the AR, VR, robotic, all of that technology, they are there to help humans to do their tasks easier. So robot can do the task for you, support you, not to take over the job. That's I see them. So when I start to McAvoy, I spend a lot of time thinking about the future of construction. Especially McAvoy is a modular construction company where we do building not in a really new way, but we try to be innovative. It is a new way for a lot of people, but I believe it should be the way to be applied. It's a new method of construction. So as we mentioned before, virtual reality. So it's my own experience when I start to go to the industry. We know the virtual reality in the university, but at the day when I bring it to Magavoy and we start to do some work with that, it is the kind of mind changing for the researcher that when you actually apply your research or your technology in the factory floor, you learn a lot more from them. You know what you need to develop to. So as you can see in that pictures, one is the architect guy from Magavoy, the other guy is the structural engineer. They can be in two different locations and we set multiple users that they can communicate based on the VR environment. And we did mention about augmented reality. Again, it's another tool which I really believe can benefit everyone. At the moment, the only point to hold us back is just some pieces of software. But the technology is there, it's easy enough to be used. That's an example. We have it done a similar concept we did in our factory. We put the HoloLens from Microsoft to one of the few of our workers in the factory. And because we build all the building inside Magavoy factory, so we can kind of play around with them. We let people get in the building, try to do some work with the AR, and see how do they get on. So let me change the topic to something a little bit different. The construction industry, we kind of stay behind, to be honest. But then when we see for modular construction, we need to transport the building, which is quite a challenge. The building normally is designed by our engineer to be stable on site, all the Eurocode and calculation. So we see in the Formula One racing, people do wind tunnel analysis just to see how efficiency, what the kind of wind force to the car. For us, the building is a kind of making a part of the building is like a little car, and we have to transport the building. So we apply the same process. You can see that is a lorry leaving Magavoy's factory, and that is a twin digital model of that lorry. The lorry drives 60 miles per hour in the motorway, and it's really advantage for the company and also for the design team to predict the force and the effect of the wind on it. So that is an example of the software, and that is how we apply for one of our building. Don't be scared of this, that is difficult. To be honest, with advanced software and technology, we can set up a kind of standard, worst case wind tunnel, that everyone in the construction industry can quickly put your building in that wind tunnel. Even you give me your IFC or FBX, I can put your building in the wind tunnel and run it through the wind tunnel to get some result. Get back to the topic of robotic. So as you can see, the picture there actually is from a Mercedes factory. I get really impressed with that picture as an engineer-minded person. I say, yeah, they're making a car under a robotic hand. Can we do that the same in Magavoy Group, or even in modular construction in general? The building is in the unit of 3.5 meters by 12. It's not much bigger than the road drawing, see? So if they can do it in a production line, it can be in the future that we can do the production line of buildings. And as mentioned before, housing crisis, shortage of building, whatever you name that, production line also save time, effort, and money, and especially you have more control of them. So to start with, I mean, everything had to start from some point. I could not go and buy a few million-pound robot and start to play with them. So actually, in the digital world, is really advantage. I contact ABB robot company, and I told them, can I have software to visualize, just to put some virtual robot to play with. And they're keenly to give away a piece of software that can model the robot. So those two robots actually to do welding. It's really beautiful piece of software. It can connect to VR, which I can virtually see my robot. It has a function that I can move the robot in VR to do a task, like normal task, and then it remembers my action. It's just a simple file of code of wherever I bring the robot to. So it remembers when did I move it. And then the model you see there actually is an imported model from McAvoy frame project, frame of a modular building. So this kind of thing I see that is a digital construction, maybe step for me, that everyone who want to plan a factory or plan a new production line, do that in digital world. It costs basically only time. And I really hope a lot of people can start to play with them or practice them in their company. So again, the benefit, I just want to summarize all of that I just mentioned. At the end of the day, digital construction is a great tool. It gives you a safer environment to work with. If something fall down, no one died. It's speed up your time, and also for me, it's a sustainable way. Imagine how much of waste have been done in the normal traditional construction. We sat in our factory in Lisbon in Dungannon office. It's surprised that the waste company questioned us why you don't sell the waste to us anymore. But we told them we don't have any waste because all the material cut off, we all recycle them, and even we design, the piece of plywood for a project. All the pieces, they go together. And our cut off normally, I can see the strip of like 20 centimeters. Never see anything bigger than that. And thank you all for listening, and feel free to ask me some questions.
Any questions for Paul? Or you let them off now? I think you're good.
Okay, thanks.
Thank you. Thanks very much, Sean. Again, just sort of lets us see just what local companies actually, working just 30 miles up the road with us, how they're embracing those technologies and how they're obviously advancing their business doing that. And I think it sort of, gives us all food for thought as to, as David says, what we need to be doing in terms of our curriculum, what we embed in there, and obviously what other companies maybe need to be looking at as well, and what they bring forward. I have asked everyone to condense their talks from here on as much as possible. We're massively over time. So if someone's sort of rapidly going through, it's because we've forced them to, it's not because of the presentation stage, so you hope you'll excuse. So I'd like to invite Owen O'Shea from HumSmart up. Just to give Owen a wee bit of an introduction, Owen was a KTP associate with a local company in Enniskillen called Roofscape, and it was in conjunction with the college here. It was very successful, led by Fiona and followed up by myself, and eventually they actually sort of set up their own company from that called HumSmart, and I'm not going to steal the thunder on it. Owen give a wee bit of information on himself. We need this every day. No problem. Okay. There's been lessons learned in technology today by us.
Right, Stephen's told me to keep it short, so
Yeah.
keep it short. So, yeah, as Stephen said, Owen Shea, chartered architecture technologist by trade. And I work with a company called PimSmart. The CAT registered practice, and basically when we started up, we really wanted to start up fresh with an approach would have been mindset. So that's sort of where we tailored our approach to projects. As Stephen said, the company came through formation through a knowledge transfer partnership between RuScape and Cladding Contractor, which was sort of a unique scenario at the time anyway. Even at this stage, a lot of the contractors, Maxwell aside, a lot of contractors and designers in the industry would still be coming to grips with them. So to actually have a subcontractor looking at it all those years ago was a sort of unique opportunity. So between RuScape and Southwest College, that a PPP partnership and with myself leading the charge as such. Through the process, we had lots of different names on both sides of the fence. So for the company, having the experience and technology available in college really helped on live projects, and then vice versa, going back to the curriculum, etc. within the college. So I'll not dwell too much on that, but the one thing I've been asked to talk about today is, as part of our investigation in BIM and our approach to work generally, one of the things we did look at quite closely in our partnership with the college was and so just some of the sort of drivers with technology in general in the industry, and I'll sort of tailor a wee bit towards these. Majority of our practices in Northern Ireland are small, micro in many cases. So we don't have a lot of personnel, and we don't really have R&D departments, things like that there. So we have to learn to do more with smaller people or less people. As David showed in his slide there, a lot of our dwelling stock, but even a lot of stock generally buildings are in place already. So there is a growing need for refurbishment and extensions to buildings. So we need to be smarter about how we capture that data and improve on outdated design and performance. Obviously, they have our government targets, and of course, BIM being a big one. Government push there to push the industry towards a better performance. Sorry, I'm kind of rushing here, but I'm trying to get through as much as possible. As Johannes and David also sort of touched on, surveying methods have largely gone and changed over the years, but there is a technology pull. The technology is there. It may not be perfect just yet, but it's certainly there to get us, as Johannes said, 80%. We can get that far. Obviously, traditional surveying is time-consuming and prone to human error. But modern standards now are much, much tighter. The client wants better standards now, so traditional surveying just doesn't really cut it anymore. So some of the things we looked at, one of the sort of bigger projects we did with college here was a local fire station. It was more of a test case for us, and we actually developed it into a case study and took it to an international conference. But one of the growing needs for geospatial data is in terms of refurb and reuse of existing buildings. As I said earlier, we have a lot of existing buildings around, and due to government targets in terms of planning, conservation, environment, etc., we are going to be reusing a lot of the existing stock out there. So we need to have techniques that allow us to capture better data to reuse. One of the more interesting ones we also looked at was in Dungannon Barracks. So we had this very old ornate police building. I think it's unique, isn't it? For a police building to be designed to such a standard, but that's actually it there, and that's actually the point cloud data. So it takes into account, it takes in all that information in the surrounding area as well. It's on quite a steep hill there. That's the King and O'Neill in behind there. Anyone knows the area of the town?
Try the keyboard on, try the forward on.
What's future technology? Is there two screens or something? Sorry, I think there's a second screen somewhere. Obviously, I don't know which way it is off. So. There we go. Thank you. So I just thought a wee video of that particular project. I just sort of jumped into the point cloud. This is using a Trimble technology, which you'll hear from soon from Cork anyway. So this is quite a nice little piece of software. It can be shared through just email, and it does all it needs is Internet Explorer to open. You don't need any special software. So your client can actually go in and take measurements, access, and as you can see from the visuals there, it's a quite complicated building to navigate. So the fact that the 3D scanner and half a day of scanning could capture all that data that otherwise would have been very inaccessible to capture. But keep going on. One of the other benefits of 3D scanning is if you have an existing building stock and you are looking to refurbish it, and actually testing out whether your new design or whether a design in general is actually going to work. So one of the projects we did engage this on was Burlington Hotel in Dublin, Doubletree. So that's what it was the day we went to look at it. At the time the contractor was looking to price the works to reclad the front facade. But you couldn't get at it. And the architect hadn't been at it, nor the survey hadn't been at it. So nobody knew exactly what condition this building was in. The reason why is because above the front canopy was this mirage of plant. So nobody could actually get up there until actually the job had been awarded and they would start putting scaffold up. But no one was allowed to actually go up and actually assess the building facade, the performance state it was in. So we took the scanner and set it in a few different locations. That's our point cloud. And developed our own design, and we used some of the algorithms within Trimble software to work out the flatness of the plane of the facade and what sort of parameters we would need to take into consideration as a contractor in order to make that work. In that particular case, we pretty much got to the stage where we just walked away. There was just too much to be done with it, and we advised the client. And actually, one of the things from the point cloud, we were actually able to see where there was water ingress. It's one of the benefits of the technology is you capture so much data that you don't necessarily go there to capture, but you have it on record within your point cloud. So we're able to see where there's water ingress, there's problems with thermal insulation, lots of problems that weren't actually within the brief. So in that particular case, we decided the risk wasn't worth it. One of the other elements was heritage. So this is Castle Pool in Enniskillen. So the behalf of National Trust, we developed point cloud of the building and some of the key rooms internally. And the benefit of this is, with such an old building, under the legislation, obviously you have to keep things to the standard it was built at the time. So if something major was to happen there, probably know what it looked like before in order to bring it back up to its normal state. So the 3D scan is actually just a capture in time of what that building looked like, what all the elements look like. So if something did go wrong, or they need to replace something, obviously they can make that happen. I'm not done on that one, it was just looking further into our fire station one. It's just because we made a bit of a case study out of it, just some of the benefits of that. The main benefit is one user can actually capture all that information in a day. And there are more quicker systems out there in terms of 3D scanning as well, but with that particular solution we had, one user was able to capture all that data and generate it for work. The benefits, as I said, being able to share your point cloud information with your client and sort of talking through what would need to be done to the building in the future to bring it up to the standard they would need for refurb or extension, etc. You're able to communicate that with photos, 3D photo environments, and take dimensions as and when needed as well. So you don't necessarily have to go with point cloud all the time. Speed and accuracy, obviously, we're getting down to 8 mil for the entire point cloud for that particular project. I'd say the extra data you get out of it, so you might go down to general dimensions but realize that there's something else there that you need to capture. If you've just gone with your tape measure and a clipboard, you've lost something. Obviously with the point cloud you've got all that data there to come back to. Stephen's getting nervous, so and obviously access to different applications. And then I'm not really going into the modeling. I'll leave it at that, but I just want to come back to that slide and say what we really want is to work smarter, not harder. So that's why we need to advance our technological approaches. Because we've got so much existing stock out there, we really need to learn how to reuse and upcycle those stock. So that's why we need better technology to do that. In terms of government targets, and not just government, now private clients are starting to look at life cycle assessments, total cost over the life cycle of the building, and obviously asking for BIM. So technology is needed to make all that sort of fit in. But basically, the message is, it's time to invest. Deliver a professional service. At the end of the day, we're a professional industry, and every other industry has advanced with the digital revolution. Construction just seems to stall. Anyway, I'll leave it at that. That was a fast pace.
Thanks, Owen. Sorry to squeeze you there. And just to reiterate the message that we need to try and sort of condense as much as we can from here in, and apologise in advance of that. So, look, that was one just sort of giving an overview of some of the collaboration that we've had sort of through their new company and the college and some of the technologies that we have available to us. And look, we're happy to talk and work with anybody on any aspect of that. And so going forward, just trying to get this technology a few seconds ahead of ourselves so that when the next person's ready to speak, okay, so we're going to introduce Kevin from Corrick here, and Kevin's going to give us hopefully a bit of an overview on all of the technologies that you have available to you and solutions that maybe if someone from industry or anyone in particular wants to actually sort of have a discussion with them about after, sort of maybe showing us maybe where things are going, and don't mention the cost of them. So I'll let Kevin, and if we could keep it
Yep.
tight as you can. Apologies.
Right, hi everybody, my name is Kevin Colwell. I am responsible for a company called Corrick in Northern Ireland, geospatial consultants, and what we do is we're in partnership with companies such as SenseFlight, Trimble and GeoSlam to provide a lot of kind of hardware out there to allow you for data collection. I know Stephen has asked me to go through this very, very quickly, so as this is a presentation on kind of drones, I'll fly through it, excuse the pun. I'll be as quick as possible. So our mission as a company is to profitably help as many people, businesses, organisations as possible to be as effective as they can. Our locations wise, where we're located, we're Liverpool, Huntington, Dublin and Craigavon. We provide all sorts of things from sales, training, field support, office support, working with companies. Just to give you a very, very quick snapshot, Corrick, and we do an awful lot of stuff with regard to geospatial hardware and software, but just to kind of give you a really, really quick snapshot of just images, like, you know, from SX10's laser scanner and total stations provided, you know, to a thing called like the GeoSlam, where you can actually walk around rooms and get a layout plan from a handheld scanner and to walk around. It's handy for doing like floors of buildings and things. Down to kind of fixed wing drones and rotary drones. Another again, obviously, look, software, hardware. We can even put, you know, scanners in the back of vehicles and quad bikes. Laser scanners that can do 1 million points a second, 2 million points a second, to 26,000 points a second. So even looking at the HoloLens on the Trimble hard hat and things like that. To give it a local context of what Corrick do, you know, we work with a number of companies, but one of our main focuses in Northern Ireland at the moment is we supply Grain and Farrens as a joint venture for their geospatial data capture and facilities management on the A6. Now, usually I don't do these presentations. I'm not a drone guy. This is the guy, Fran, who is probably, if any of you were at the thing in the Europa, he's Fran would have been speaking, but just to kind of give you an idea of how people fit into drones, like Fran's BSc in geomatics, he's 12 years, he's been flying drones since 2012, he's CAA approved, but I suppose the key thing with a lot of this technology is you don't need to be an expert to use it, it's about what you do with the data afterwards. Just to go into very, very just quickly about drones, look, there's so many different types of drones, you know, from DJIs to Amazon, who apparently going to be delivering their post in a couple of years, you know, using with Sky Sports and things like that. All different shapes and sizes. As you can see in that image there, a picture of a guy in the left image, that's a military drone, to a drone the size of your finger. So how Corrick became involved in drones was with the Department of Agriculture in Northern Ireland and the Forest Service. And you can see by that image what they were looking at the time was looking at sort of forest fires and things like that, and where they were sort of being started and to investigate them. And, you know, they would have probably originally sent kind of traditional survey methods up there with, you know, GPS devices and robotics, and, you know, it's kind of a dangerous environment, and by using a drone you can fly something in, you know, very relatively short periods of time. So I suppose commercial against professional, you know, with regard to the professional drones that we use, it's their ease of use, build quality, endurance. I know you're trying to get me to floor through this. Some of the benefits from aerial collection to ground instruments. You know, with a terrestrial robotic or a GPS, you're recording about 500, 600 points a day. You know, what do you record? You know, or what did you not record? So in other words, if you come away from site and you use a drone to create a full thing, you know you're the same with using the scanner or things like that. You know you've left the site and you've not missed anything. So it just kind of takes the pressure away. And then look, at the end of the day, you only survey the area of interest required as well, and when required. And look, you can even sort of do these surveys on a weekly basis, a monthly basis of the same area, so you can sort of see the progress of a particular project. Another benefit, obviously, even if you just look into this image here, you can see a lot of, you know, danger and things like that. And I think one of the main things with a lot of this, from scanners to drones, is it's a lot of it's to do with safety. You know, you're not having to close roads, you're not having to set up work, so you can be off site. You can launch this by hand launching it, you don't have to wait for access or permissions to site, and it's just less manpower, less equipment equals less money. And at the end of the day, it gives you easy data from photos, videos to ortho images, from CAD files, DXFs, shape files, even into Google Maps or Google Earth. So I think one of the main things with drones, and the same with a lot of technology, is a lot of it kind of coexists with each other, and it kind of complements things. So, by far, drones aren't there to kind of completely replace people who use GPS equipment or robotics. There's always still a use for it. But it's an addition. So the two types of drones that we would generally do would be the fixed wing and the rotary drone. And just to kind of give you an idea of a fixed wing, I suppose a comparison of what they're most suited for, coverage with a fixed wing is for large areas, small areas. The rotary drone is for kind of structures or things like that, for building surveys and things like that, whereas fixed wings are more for earthworks and larger areas. So you can see down here, like difficult with 3D mapping of infrastructure with this, but it's much easier with this because you can fly it around the structure. You can use a number of different sensors, cameras, thermal, infrared, RGB, and even with the Albrus, with the copter drone, you have a multi-with camera. What's unique about this drone is it can actually look up. So if you can think about going under, say, for example, a bridge structure to look at conditions, a lot of drones seem to be based around, say, a camera and a drone built on top, so you can't really view up. As you can see, it's hand launched. I'll not go through too much of this stuff. I can talk to you afterwards about it, but just the weight of an EV, by all means, go down at the end there and pick it up and see how heavy this thing is. It's probably the weight of a family box of cornflakes. So just if you can think from the safety aspect of, if it did come down, different sign sensors. I don't know if you want to play this video. Don't think there's any sound, is there? So this, it's about 2 minutes of the video anyway, but I can send these on to you anyway, but it just shows you that you can fly over particular areas with high precision on demand, and just going through it. So I can send you on these presentations at the end anyway, if you need to. Going into the copter drone against from the fixed wing. Again, it's used for buildings. It's it's relatively light and weight, 22-minute flight time. It's designed for remote inspection and 3D modelling. As you can see, the heading here can look up. There's a lot of sort of advantages of using this. Triple head view. It's relatively safe to use. You can set situational awareness from a safety point of view, so you don't need to be an expert in drones to fly these things. You can set a distance away. So if you're doing, say, a dam, wall, or a building, you can have it that it won't, it can stay a certain distance. It can have a distance lock away. The controller, for any of you gamers out there, it's very, very similar to something that you'd see a person using a PlayStation 4. It can actually be fun to use as well. This is the video of Bounty Albrus. Because there's no sound, I'll just go on to the next one. So this is just basically the software then that you use to fly the drone, so you can select your flight. This is something from a desktop. It's just I'll scroll through it very quickly. So what you're doing here in the eMotion software is you're selecting the drone, you're selecting the camera, and you're out and you can use any kind of imagery from sort of Bing Maps to Google Maps. You can see here, you can switch over, you can pick your so you can draw a polygon around a particular area that you want to fly. You can bring in kind of a map which will show height, so you can be sure that you're landing and launching. I'm just going to go through this very quickly. Once the drone starts, it climbs to a particular height of about 100 or 120 meters, and then follows these lines. So it just takes photogrammetry, images along this. And you can see that you've got all your usual flight controls, wind speeds, and things like that. So this all does all this. It comes into land. And even going then just using the Albrus, just to give you an example of a copter drone. You can kind of do it around a particular point of interest. If that was a building, or you can, that can change the different type of study. You can do a square around that or whatever. So it's much quicker to do. So that's just a very brief overview. When you process the flight data, then you process it in Pix4D. This is one of the chief surveyors on the A6 in Toonbridge at the moment, a guy called Nick Kelly, and while they still use traditional total stations and GPS, this is what his office looks like on a daily basis. Now, I know it's never usually that weather always in Northern Ireland, so but yeah, that just gives you an idea of, he's flying about 2 or 3 days a week, and the amount of information he's collecting is phenomenal. If you look at just kind of individual stuff, what would take a full topographical survey about 2 or 3 days, he's flying it in about 17 minutes. So it just really goes to show that being able to capture the data is exceptionally quick, and then he has more time to analyse the data and do what he needs to do with the data. So what we would normally do with this data is we would bring it into Trimble Business Centre, and this is the imagery from an area of from the A6 up in Toonbridge. So you can kind of see the kind of imagery that we're getting there from point clouds, so we can do analysis on sort of what's to come in and what's to go out. Again, it gives you can get a 3D contour lines. You can see as well just how clear the imagery is on the roads, on the existing road. I think one of the key things here is he's able to fly that, and traffic is still moving on the roads. So there's no aspects of shutting down. You can see your GNO file, your road file, and you can see that it fits perfectly along with the data. So the imagery you're collecting with an EB is you're getting about 3 to 7 centimeters in accuracy flying at this drone, because it has an inbuilt GPS. Again, I can send you these videos at the end of this, but you can kind of see anyway when I'm flying, because you can see obviously grains, particular colour of the grains plant. Again, you can analyse this data. You can take out stockpiles and you can analyse them separately. Gives you a full 3D model, and you can then review your images, and then you can produce a report at the end of it to say how much is in a particular stockpile. This is something that Graham's have online at the moment. There's an A6 YouTube video which kind of gives you a bit more of an idea of the data they're collecting. You can see the outer fence line with the road scheme there. There was one video they put up of one of the guys catching a drone, but he kind of fell backwards when he tried to catch it, and sort of very bad colourful language, so I think Graham's took that down. I can send that to you privately if you need. As I said, there's a lot of information there. Again, there's a lot of stuff that we can cover, like you can combine laser scanners with copter drones, type of imagery from a lighthouse down in, I think this is down in Dublin somewhere. So you can see the first imagery was taken with the Albers, for example, and you can see it's not as clear data as you would like it to be, but it's great for getting around here, getting a good study there. If you go on further down, you'll see, so you can see the imagery there was taken with the Albers, but then once you use then a terrestrial scanner, you can see the data is coming in an awful lot cleaner, and cleaner lines, and things like that. So again, I can send on these videos at the end. And this is just a very, very quick thing with the SX10 for a laser scanner, for example. So you can, with this particular terrestrial instrument, you can draw a polygon on the tablet when you're out there, and you can do stockpiles, and you can do measurements and things like that. So this applies to pretty much everything that's out in the geospatial environment, and you can run a report on that. Again, look, there's so many different applications from looking at using a thermal camera on power lines. These are just a snapshot of a couple of companies that we supply, for example, like the EV2, even the Irish Minister for Communication and Climate Action has one. So thank you. Apologies, it was very, very quick.
Apologies again, Kevin, for trying to push you on there, and we are sort of coming into land from Drone Speak, and invite a couple of speakers, and we will try and get you to lunch very, very quickly. look, that's extremely interesting stuff, and Kevin obviously didn't get enough time to display the wares that we have and the technologies that are available. He is here all over lunch. I'm sure he'll give you a card and so on. If you want him to call out and have a talk with you, he'll certainly run you through all the technologies that they have available to you. The next speaker is going to be Fiona Brazil from the college. She's the project sponsor for a new campus that we're building in Skillon called the Cairn Campus. We're extremely proud of it, and it would be remiss of us if we didn't take the opportunity to give everybody a quick look at what we've actually done to date and where we're at. Thank you.
Afternoon, everyone.
Can I speak into the mic?
Yes.
Just can't hear you.
So, the Erin campus is going on site shortly. We have, I can figure out how to use the mouse. We have 5 acres. We're building on a very historic site where we had a listed workhouse, then we had a hospital, and that's demolished. It's now a brownfield site. So we are proposing to be very demanding of our contractors. We're going for a passive house premium, rating outstanding, and we would like to bid level 2 as well. So the contractors are stepping up to the challenge. We're coming out of the pre-construction period at the minute. They're working really hard on it. We've a set of our own consultants, and we have consultants on the contractor's side, and this is ultimately what our campus will look like. So there are very high standards to meet, and if we didn't work smart and we didn't work digital, we would not be able to go through the volume of information we're dealing with in the 15-week period. So we're the only passive house course provider in Northern Ireland. We're only one of only 2 in Ireland. So that to us means that we're not building a building, we're building our income generating. So this is why it's so critical that we go beyond having a model we use for assets management. We're using the model to develop new curriculum. So premium means that we're producing a building that is essentially producing enough of its own energy to be off-grid and be self-sufficient. So that cuts our running costs. And in addition to that, the plan is, behind the mouse, that we develop new curriculum from it. So what we want the data for is the key question. And we want to use it to plan the build process. I'll give you a very quick run through that in a minute. Brief the contractors during the tender stage. So we used the models during the tender stage to show the contractors what it meant to them to take the building performance to the passive house standard and the premium house standard. And we sent that out to the contractors. We're using the VR here for spatial awareness, which our staff, students and all of our stakeholders can take a walk through the campus. Our immersive designer at the back there, Pádraig McAllister, if you would please do avail of the chance to try the VR, do come up and don't be shy at all, and do take a walk through so that you can experience the spatial awareness we're trying to get to our staff. Where you can put different fit-out layouts into the proposal in the VR, and then we can get decisions on fit-out using that. The curriculum development is something we've been working on from September. So we're developing the modules of Passive House as an online course, and then ultimately it'll be used for assets management. I'm not breaking any speed records here. Can't find the mouse. Right. So this will play automatically. So this is early days with our own consultants. We talked through the build process with them so that we are very clear where airtightness is critical, because we're going for an airtightness level here of 0.3. It's 8 in the building, right? So we're going for 0.3 air changes. That's phenomenal to achieve within a big volume of the building. And we need a level of thermal bridging that's 0.01 watts meter Kelvin. That means no thermal bridging. So that's why we took the details and we worked them through in that format. And now the consultants on the contractors team are doing the same exercise. So they're bringing their design development to it. So in workshops with the contractors' consultants, it is very much about using the tool And even today, we have a new upload on a common data environment of our structural engineering. That means we can see it quickly, we make a decision quickly, we can compare the versions of the models we've received quickly. There's no waiting for the next meeting. So that speeding the decision making and dealing with the volume of information is how we're getting a much more streamlined process. So you'll see it on site in Enniskillen very shortly. Tracy Brothers are the awarded contractor. And as I say, before you leave, please do try the VR headset. We're not going to play the video now, thanks to the time cuts there. We'll send the link out for it, okay? So, thank you.
Thanks, Fiona. Whenever I asked you to run through that quickly, I didn't expect that you would take it as literal. But no, absolutely, all the slides and everything, presentations, videos, etc., will all be supported in an environment that we would send a link to anybody that's registered. So if you do want to see those, then we'll certainly pass those on. The final speaker, and definitely the graveyard shift today, but it's Timothy Hegarty, and Timothy wanted to come along to give us a bit of an insight on some aspects that they're dealing with, where they're obviously looking to work with children, not steal the thunder of it. But Yanis mentioned earlier about the fact that there's a definite lack of people out there that have certain skills, and I think, David, you also mentioned that academia, etc., need to be looking at the curriculum and build that in. And I think you've sort of come up with a possible solution to start at the very youngest age.
Yep.
So again, not to pressure you, but if you could try and do it as quickly as possible. So, thanks.
Good afternoon, folks. I'll just wait until the video or the presentation's up and running. I'll probably glance over a lot of what people have talked about earlier. The main gist of the presentation is about Minecraft. Can I just ask for a show of hands as who's heard of Minecraft or whose kids play Minecraft? All right, okay. This is a project that I've been working on with the University of Ulster. I'd like to explain them in very simple terms to people. Basically, all the components of a building, and this is an example of a car. Every component is an object, and every object has dimensions, a manufacturer, a warranty, and all the associated information. If you think of an F1 car, that's all the components, and they're all intelligent. There's a lot of sensors relating back to the pit lane and informing the pit lane of the fuel usage, the airspeed, the ventilation, the wear and tear in the brake discs, so that they can prepare for when the car needs a service. And Yanis talked about the digital twin. Effectively, all information that the pit lane gleans from the car allows them to plan the next pit stop. So that's the way it's going to go with buildings. We touched on earlier regarding some of the analysis. I think Hang mentioned the analysis. The BIM model allows us to run a lot of detailed analysis on the structure. I think Yanis mentioned about all the sensors, and all this information can help the building owner, the asset owner, manage the building over the life cycle. startup cost of any construction project is identified as 15%, whereas the life cycle costs are 85%. And this is what's driving the government mandate, and that they want to reduce the cost of building maintenance over the life cycle. Just skip through a few slides. This is the global market for BIM, so it's not just in the UK, it's all across the world. There's mandates from Spain to Russia. We'll run through a few of these slides quickly. This was the laser scanning. This was the Titanic and how complicated the structure it was. This is the different permutations of the facade of the Titanic. This is 4D planning. So you would have the building model tied to the program, and you could actually run a video that's allied to the program and see how the building would be constructed. 3D printing, touched on the AR, VR. That's a very good video with the Dyson HoloLens one. Robotics. Now, to bring it to a local level, when I visited the Dalriada mine, it'd be controversial, but they were using robotics for some of the mining equipment. This is just an invention called Zero G, and this is the reduced vibration white finger. That's already been used in America and in Heathrow by Balfour Beatty. That was the Dacre helmet that we touched on earlier, designed for manufacturing and assembly. This is machine learning. This is at a very basic level as far as the footage taken from construction sites. The program is intelligent enough to realise what's a worker, what's an element of plant, and record all that and tag it so that it's very easily searchable as well. RFDI we talked about. Intelligent buildings. I'm just flying through here. This is the latest cloud platform. This is a model of Belfast that's been done with a 15 centimetre accuracy. And you can purchase a license for this program and upload your model, and that would contextualize the model within Belfast so that you can get a multitude of views for the purposes of planning. They're talking to NIE and NIE Water, and they'll be able to feed in the parameters regarding electricity and water supply into the model. So this is mentioned earlier. There's a huge skill shortage in the trades as well as in the technical aspects, and there's a lot more requirement for IT skills in the construction sector. In the recent farmer report, he identified that industry needs to engage more with education to produce the graduates that we need. So get on to Minecraft. So it's a sandbox game. It's a bit like Lego. At the moment, you have a box of blocks and you can build whatever you want. Some of the creations. Some of the things you can make Belfast City Hall, Guildhall. This is a video for the Stroll campus. I don't know if we've got sound. This was a number of school kids in Armagh, and they recreated the Stroll campus in Minecraft over the space of a week. That's the architectural drawing. It wasn't far off. So Minecraft's actually been introduced to schools in Northern Ireland. The Minecraft Edu, and it's been used in a number of subjects in schools, from geography to history. This is some of the Minecraft BIM overlap. You can actually bring in a Revit model into Minecraft. The Ordnance Survey in Northern Ireland have created Northern Ireland in Minecraft. That's a portion shown up here. Regarding STEM, there's different coding elements. Mentioned HoloLens earlier. There's different apps coming into Minecraft where kids can actually walk through the models they create in Minecraft. Basically, this is a small world that we created where kids can go in, and this is the Minecraft version of Minecraft. They have to put up hoarding before they can start building. If they wear PPE before they start building, otherwise they get fined. Each of the blocks, we've created some specific blocks that are more realistic to life. The cavity wall, they've all got costs associated with them. They have to put in foundations before they can start building, which isn't like the normal Minecraft. And there's a whole lot of other features that we've put in. We basically took the GCSE construction syllabus and recreated it in the Minecraft game. Again, that video we should share with you. So we created an associated iBook. It's a 90-page document. This one was with Morgan Sindel, and we've got all Morgan Sindel's photographs through it. And it has different tasks for a teacher to take kids through different aspects of construction, teaching them about careers, teaching them about volumes and area, and new values regarding temperature, and a whole lot of other sustainability aspects. It's been very well received globally, and it's starting to be used by other organisations. This one was by Gilbert Ash and Belfast Harbour. They used just a normal Minecraft game, but you can see the Minecraft model on the bottom right and the actual building on the top. And we see this as a great CSR tool for the construction industry. It's just some of the organisations that we've dealt with. It's a real shame we can't show the last video because it's quite funny. If anyone's got any questions.
How do you get it?
It's downloadable from the website. You just have to email us and we'll give you the username and password.
Thanks very much, Tim. Again, I suppose anybody that's got young kids out there, or nieces, nephews, and so on, again, the presentation will be sent on, and the link will be there to yourselves. Tim, and obviously, if they email yourself, you can send them back passwords, etc., to get into the game. Look, thanks very much for your patience, folks, and thanks very much for the patience maybe for the speakers in terms of technology, etc. there as well. I'd like to thank everybody that talked, from Yanis, David, Hung, Owen, Fiona, Kevin, and obviously Tim there at the end. I find a large portion of it anyway very interesting and food for thought for myself. And again, from the college point of view, I think it's definitely stuff we need to be embedding more and more into our curriculum and mature courses. I hope that lunch hasn't been dried up and burned, and that Peter will not turn us away at the door at this stage. But It's just basically out and across the hall. Again, just a quick thanks to our sponsor, and a quick thanks to a lot of people that brought this about within the college itself. And I'm going to name Linda because she's done quite a bit of work, and I'll thank everybody else as a group. Aidan's still at the back door. Anybody that hasn't registered that still would like to get all those presentations, then please do so on the way out. Enjoy lunch. Thanks very much for coming.